Such an essential sound. From the screams of TIE fighters to the growls of muscle cars, the whine in MotoGP to the whirring gyros of speeding hover cars, the way an engine sounds can make or break a game. But it often seems that there's so much to think about when putting engine sounds together. Acceleration, deceleration, turns, vehicle pitch and roll, air noise, camera perspective, ground surface, the weather, and audio feedback from objects near or on the road in the form of reverb from walls and tunnels and additional ground surfaces. Ever notice that you can hear glass under your tyres if you've knocked out a headlight in GTA 5? All of this detail, all of this work for one part of the game. So I thought about some ways of making this process simpler. If we start off with one simple input, the vehicle speed, how can we build up a basic engine sound? So in this tutorial, we'll take the speed of our vehicle and we'll use it to alter a sound cue. We'll embellish that cue using other simple rules around pitch and volume. The principle here is adding simple layers at each stage of the sound design so that the end product sounds more complex and nuanced. The main driver will be the crossfade by param node in the sound cue. We'll create 3 versions of the same cue, adding an extra layer at each stage. We'll round that off by creating a tremolo effect in the vehicle blueprint. This will provide an extra layer to the sound and show you how you can start blending different sounds together to get a richer and more detailed engine sound. My focus in this tutorial will be on sci-fi sounds because I'm using assets from a personal project. Whether your vehicle is from the future, from today, or from 100 years ago, the same principles will apply. Just make sure the sounds you use can be looped seamlessly. Unless you have an existing vehicle project, I recommend you create the Vehicle Advanced template that comes with Unreal Engine. First, we'll create a sound cue. So in the browser, right-click, Sounds and Sound Cue. You can call that whatever you like. Once you've made it, open that up. And here, if I show you the blank version, here we're going to drag in a reference to the WAV files that you'll have imported. And drag them in. And with them all selected, we will tick the looping checkbox here. And keeping them highlighted, right-click and add a crossfade by param node. And that will automatically hook them all up. So this is my crossfade by param node as I've set it up for this project. You can see I've put a param name in here, RPM, and we'll use this to reference the node and effect these changes from the vehicle blueprint. When we set the vehicle blueprint up, it'll produce a value between 0 and 1, with 0 being idle and 1 being the maximum revs or speed of the engine. I've decided to use 9 WAVs, so I've split the 0 to 1 range into 9 sections. At 0, we're going to have our first WAV playing. So that 0 input there is this one. That's our first WAV file. And when our RPM reaches a value of 0.12, we're going to start to fade out that first sound, and also at 0.12 we'll begin to fade in our second sound. By 0.15 the second sound will be fully faded in, and the first sound will be fully faded out. And I keep doing this all the way down the list. And you'll see at the very bottom here, we've got a final value of 100. Now that is way beyond the maximum that the RPM value should ever reach. But by setting the value beyond the point where the player can feasibly get to, it means we're always going to get a sound from the engine no matter how fast the player goes. The rev value, if it's limited to 1, won't produce any sound once it reaches above 1. Before we finish in this sound cue, we'll add some attenuation. I'm just using a basic attenuation setting here. It doesn't really matter what the settings are. It's really only useful if you're using reverb or if you have other vehicles in your project. If you don't already have an attenuation, just click the Create New Asset Sound Attenuation here and then just use the default settings. These are the settings I have here, but there's nothing particularly special about them. So let's save our sound cue and we'll jump to the vehicle blueprint. So I'm going to show you the blueprint inside the vehicle advanced map. So I'm referencing the vehicle blueprint in the vehicle advanced example map that comes with Unreal Engine. And in here, in the update comment, you'll find the event tick and the sequence node. I've added 2 more output pins to the sequence node. We'll deal with the first of those here. Now to start with, if you're using the vehicle blueprint, it already comes with sound, this engine sound audio component, and that will automatically play. We don't want that. So if we untick the auto activate box here, or you can delete that audio component if you prefer. Next we'll create our own audio component, so add component and then audio. And the sound that we'll select here is the one that we just made. So for me that was SC Engine 01. And then we want to pull in a reference to that on our event graph. I've already done this, but I've called mine tutorial engine. So from there, I want to drag out and we want to get the set float parameter node with the in name of RPM. That's the same name that we gave our crossfade by param node in the sound cue. So we are linking these two things together. Now we want to create the infloat value. What is the value of the RPM? So for this, we're going to get the vehicle's speed. From the details panel, you'll have a vehicle movement at the very bottom of the list. Drag in a reference to that, and from there we want the get forward speed node. From that, we are going to add the absolute or ABS node, absolute float, and that, as it says there, returns the absolute, a positive value of A. That's a really useful node because our vehicle can go into reverse, so we can get negative values for the forward speed. That could be a little bit of a headache if we're trying to set up our sound cue effectively. So by converting this to an absolute value, always a positive value, even if the vehicle's reversing, we'll still get a value in the positive. And we can use this in our next node, the map range clamped node, which we'll add from the absolute. If you're not familiar with this, it takes in a value between the in range of A and B, and it outputs as a value between the out range of A and B. So in here, we'll have our value. The range of that value can be from 0, where the vehicle isn't moving, to our maximum speed. In the vehicle advanced example, I've set that maximum speed to 2000. In my personal project, that max speed is 6000, so you might need to tweak it if you're using your own project. And then we are converting that range to a value between 0 and 1. So that return value is going to go into the infloat of our set parameter node, and that will power the changes in our sound cue. Now, because I'm a fan of debugging, I like to see what's going on, I've added the print text node after the set float parameter, and into that I've added the format text node, and we can add some curly brackets to get extra options, extra input pins to plug things into. So I've got one for the vehicle name, because in my other project I have more than one vehicle, and then the RPM value will be input as well. And that's it for stage 1 of the engine sound cue, the simplest setup. So we are taking the engine speed, we're converting it to a value between 0 and 1, even if the vehicle's reversing. We're sending that to our sound cue. The sound cue will react to that value by fading in and out through the different WAVs that we've connected to the crossfade by param node. Let's try it out. Let's have a look at it in the vehicle advanced example. And let's have a look at it in my other runner. So you can hear the engine sounds changing as our speed increases. decrease our speed, you can hear that we're going back through those same sounds, but in reverse. When we do reverse, we get the same effect in the opposite direction, thanks to that ABS node. Okay, so that's a very straightforward engine sound, which is another way of saying it's pretty bland and boring. So how can we add some colour and texture to this sound? How can we add some extra detail to make it sound a bit more interesting? Well, there are different ways we can approach that. We could change our audio assets altogether, giving them more character before re-importing them. We could add a second set of engine sounds and use a mixer node in the sound queue to balance the volumes of both sets of sounds. So this is an example of that kind of setup. At the moment, I'm just using the same sounds, just duplicated. But here we have two separate sounds going into a mixer, and we're giving priority to the first or top sound, and that is getting linked into our crossfade by param node in the same way that we have in our basic setup. As we work through the mixer, we're increasing the value of that lower sound and then gradually decreasing the value of the upper sound. That'll change the colour or the texture of the sounds. If we had something that was really different for the lower sounds in each pair, that will give us a different textured sound by the time we reach our top speed. But let's limit ourselves to sounds that we've already got. One thing we can do is to add a continuous modulator node to change how each WAV performs over time. We can link this to the same RPM value that we're getting from our vehicle blueprint, and we can use that value to change the pitch of each WAV. Add the continuous modulator node to each of these layers and plug them into the crossfade by param node. Now we can modify both the pitch and the volume, but as we want to keep our volume pretty static, we only want it to be affected by the player's input, let's just stick with the pitch. The values I've added here are somewhat arbitrary. Just experiment and see what works with your setup. Make sure the parameter name is set to RPM. It seems like a good idea to keep the continuous modulator nodes somewhat similar to the values we've set in the crossfade by param node for each of these inputs. So for this first input, I was going to fade this one out between 0.12 and 0.14. So on the continuous modulator, I've changed the max input to 1.2. So this modulator will stop applying the pitch modulation when the RPM value hits 0.12. The min and max outputs, they're going to be what affect the pitch itself. So at 1 we have ordinary pitch, and at 1.2 we've lifted the pitch up. All of the continuous modulators use the same parameter name, and they all have the same outputs. Only the inputs are going to differ, and that just corresponds to the crossfade by param value for that particular input. Again, this is an area it's useful to experiment with. Using a lower min output will force the WAV to begin playing at a lower pitch. Whether that sounds good with your setup depends on the sounds that you're using, as well as the crossfade points you set in the crossfade by param node and the vehicle's acceleration. So you can see that even by adding in this simple thing, we're starting to add extra complexity to the way that our sound performs. So let's try this one out. Again, we'll do it in the advanced blueprint first. So we're going to load in our new sound here. Always useful as well, by the way, to duplicate the sounds rather than editing them. That means we have the original version. We can go back and make changes or restore that version if we want to. So this is with engine 2. And then we can hear the pitch effect coming into play there. Let's try it on the other runner. So again, putting in the engine 2 sound. but it's doing it in a reasonably blended way. It sounds like the vehicle's changing gear as it accelerates and decelerates. That's a pretty clean sound. There aren't any breaks in the sound, and it's all playing pretty smoothly as we accelerate and slow it down. But is there anything more that we can do? One minor change that we can make to smooth out the transitions between the waves a little more is to add an enveloper node. Enveloper, not quite sure how that's supposed to be pronounced. I'm just going to call it the envelope node. So this node lets us adjust the volume and pitch over time. Now we're already getting a similar effect using the RPM value because that value is a time-based value generated by our vehicle blueprint. But the envelope node gives us greater control over how each of the waves fades in as we move up and down through the RPM. So if we just get a standard node, you'll see that we have two graphs here on the left panel. By default, both have a single key. That first key, let's set its value to 0, and then we'll add a second key just by right-clicking and add key, and we'll set that value to a time of 2 and a value of 1. Hit these arrows just to zoom out a bit more, highlight both, right-click one of the nodes and auto, and I'll get a nice smooth line between the two. This is going to fade in our sounds coming from the crossfade biparam node over a 2-second period. Again, depending on the vehicle speed, that might be too fast or too slow, so experiment to find a setting that works well with your setup. Now one thing to bear in mind as well is that both curves are multipliers of the values being input from the previous nodes. So for volume, for example, volume will be 1 for the WAV by default. If we changed our volume here to 2, when we go through our enveloper, if we'd set this value to 2, the final output from this node will be 4, because we'll be multiplying each of these in turn as we go through. So there is one more thing that we can do here, and that is to add some randomization to pitch, just in case we're spawning 2 or more vehicles using the same sound cue. That's going to reduce the likelihood of any strange effects if the exact sound is being instanced twice in our game, especially if the assets are right next to each other. So for that, we're adding a modulator node and have set the pin min and max to those ubiquitous values of 0.95 and 1.05 respectively. And again, just left the volume value alone. Demonstrating the differences between this engine and engine 2 is a little harder because it's just smoothing the changes in the volume and the changes in pitch are very slight, but let's show it anyway. So we'll save that. And again, we'll go into our advanced vehicle blueprint first. We'll select it in the browser, go to our audio component and hit the arrow. So that's now input there. Compile and again, we'll do the same in the other project, this time engine 3. The Tremolo Effect. It's a rapid on-off curve that's applied to the volume of the audio. Back in our advanced vehicle template, we're going to step out of the sound cue and we're going to jump into the vehicle blueprint itself. And we're going to have a look at the second stage. So this is coming off the event tick, that second sequence output pin that I mentioned earlier. And there are some extra nodes in here, but if we have a look here, you'll find that this is, all of this is just copied from what we made earlier. So you can copy that over here. we're going to keep the original engine layer as the base layer on which to sit the tremolo effect. So the first copy will play, just as we've heard, nice and smoothly with those transitions between the wavs as the vehicle RPM increases and decreases. And the second copy will respond to the RPM in the same way, only this time we're going to use some code in the vehicle blueprint to alter the volume between 0 and 1 and back to 0 again. As the vehicle accelerates and the RPM gets higher, we'll use that value to increase the speed at which we go from 0 to 1 and back to 0 again. And that will create our tremolo effect. So first of all, with our engine audio component selected, hit Ctrl and W to duplicate it, and I've renamed mine engine tremolo. Now we're going to use the same sound that we were using for the original. So we're up to engine 3, so let's find engine 3 again, and we'll plug that in there. And from our final output pin of that sequence node we have, we're going to add a new sequence node, and from the other pin of that, we are going to set the volume multiplier for our tutorial engine, for the original engine we were using. We don't have to do it this way. You can change it in the sound cue, you can change it over here. I'm just doing it to keep things separate so we can look at this as a separate section. So from that, we're going to drag that reference in, we're going to set volume multiplier. You can just type in volume, set volume multiplier, and we're going to set that to, in my version with the assets I'm using, I'm going to set that to 0.8. So we're reducing the base layer, but not by loads. From the second output pin, we're going to take this section of our original code, the vehicle movement, forward speed, absolute value, and that map range clamped node. From the return value, right click and promote that to a variable. I've named mine tutorial RPM, and we're going to set that. We're going to do that every tick, so we'll plug that into the second output pin of that sequence node we added. Then we have that set float parameter node we were using before with the in name as RPM, only this time we're going to plug in the tutorial engine tremolo audio component, the new one, the duplicate we made. The print screen, the print text node, just the same as before. However, to the format text node, I've added a play rate and a tremolo output as well. You don't have to do that. This is just so I could monitor those values. Next, we need to create a timeline. So right click and add a new timeline. I've called mine Tremolo Modifier. Inside the timeline, we're going to add a float track. We're going to set the length to 1 second, and we're going to take loop as true, and then we'll add 3 keys, one at 0, 0, the next at 0.5 and 1, and the third at 1 and 0. This is going to dynamically adjust as the vehicle speed increases or decreases. As the speed of the vehicle increases, this will move faster and faster. As the speed slows down, this will go slower and slower. How are we going to do that? Well, we need to set the play rate. So whatever you've called your timeline, you now need to get a reference to it. So I called mine Tremolo Modifier, and here, get Tremolo Modifier with a little clock next to it. From there, we need to set the play rate. Now input for that is going to take the value for the tutorial RPM that we set earlier from that sequence node, and we're going to multiply that by a new float parameter, which I've called tremolo. By default, I put that as a value of 4. The higher the value, the faster the tremolo. So we're going to multiply the RPM value by that, and the output of that, the result of that, will go into the new rate of our set play rate node. And again, for debugging, I've just spun that over here. As the value goes from 0 to 1, we're going to change the volume of this secondary sound we've created, this tremolo engine. So drag in a reference to the engine, and then we want to add the set volume multiplier, just as we did for the base layer, only this time we're going to plug in the output, the float output of our timeline into the new volume multiplier input of that node. And again, I've routed the output of that float from the timeline to another section in the format text node, so we can print that and see the value as we run through. So I hit compile and save, and let's test this out. And keep an eye on the values in the upper left. So there is our tremolo effect. So we can hear our bass layer, and we can hear the tremolo layer working on top of it as well. So we've taken a simple premise and we've added in some extra layers, which are also pretty straightforward themselves, to add in some extra color and texture to the sound. So this version in the Vehicle Advanced Example Map is an Unreal Engine only version of my Fmod setup. I'm not going to go into the full detail in this video, but I'll show you what I'm working on in Fmod. So for our vehicle in Fmod, I have 6 different aspects to the sound. We have air, or wind moving past the vehicle, with changes in intensity depending on speed or velocity, our camera perspective, height above the track, and whether or not air brakes are applied. Next we have the actual air brake. This needs to be tweaked, but it's basically just supposed to be gaseous hisses as we hit the air brake left and right. And that section there will loop around for as long as the air brake button is held. Next we have our main engine sound with a range of parameters that change the sound based on velocity, camera perspective, weapons fire, air brakes, throttle, and how high we are above the track. We have our engine start sound, which is probably the most basic thing in the whole setup. We have our brake sound. And that will play when we hit the decelerate button. And finally we have thrust, which is the extra boost to our speed. And this uses a recording of an actual flamethrower. And this will gradually fade out when the thrust button is released. So when we put all of these things together, this is what we get. still needs a bit of work, but it's overall a much more satisfying sound than what we had at the very, very beginning, when we just had that simple movement between one layer and the next. Hopefully this introduction to engine sounds gets you thinking about ways to both generate game data to just vehicle engine parameters, and also gets you thinking about what sorts of sounds you can make. Remember, stacking simple rules on top of each other can help us to produce more detailed audio. Take care, enjoy making your own projects, and, as always, thanks for watching.